So hello, this is Jeffrey Chong, and today I'm going to cover the topic of exponents in scientific notation from Algebra 1. So using the calculator, when we enter 2048 times 1536 times 48 times 22 times 3600 and press enter, the calculator displays something like 1.304596316 E13. What does this mean? The E13 portion of the result represents the exponent 13 of 10, which is 10 to the power of 13. So in this section, we review rows of exponents first and then apply them to calculations involving very large or very small numbers. So this is a scientific notation. We got a coefficient in the front and then also 10 to the power of something, which the 5 in this case is the exponent. So using the product rule of exponents, consider the product x to the power of 3 times x to the power of 4. Both terms have the same base, in this case dx. But they are raised to a different exponents. So expand each expression and then rewrite the resulting expression. X to the power of 3 times x to the power of 4 is just like x times x times x times x times x times x times x. So we got x times x for 7 times. So we get x to the power of 7. The result is that x to the power of 3 times x to the power of 4 is equal to x to the power of 3 plus 4, which is x to the power of 7. Notice that the exponents of the product is the sum of the exponents of the terms. In other words, when multiplying exponential expressions with the same base, we write the result with common base and adds the exponents. This is the product rule of exponents. So for any real number a and natural numbers b and c, the product rule of exponents states that a to the power of b times a to the power of c is equal to a to the power of b plus c. So the next rule is quotient rule. So the quotient rule of exponents allows us to simplify an expression that divides two numbers with the same base but different exponents. In a similar way to the product rule, we can simplify an expression such as y to the power of b over y to the power of c, where b is greater than c. Consider example y to the power of 9 over y to the power of 5. Perform the division by cancelling common factors. So we got y times y for 9 times on the top, and also y times y for 5 times on the bottom. When we cancel out 5y for top and bottom, we get 0y on the bottom and then 4y's on the top. So we get y to the power of 4. In other words, when dividing exponential expressions with the same base, we write a result with the common base and subtract the exponents. So y to the power of 9 over y to the power of 5 is equal to y to the power of 9 minus 5, which is y to the power of 4. So for any real number a and natural numbers b and c, such that b is greater than c, the quotient rule of exponents states that a to the power of b over a to the power of c is equal to a to the power of b minus c. The next rule is the power rule. Suppose an exponential expression is raised to some power. Can we simplify the result? Yes, of course. To do this, we use the power rule of exponents. Consider the expression x squared to the power of 3. The expression inside the parentheses is multiplied twice because it has an exponent of 2. Then the result is multiplied 3 times because the entire expression has an exponent of 3. So it looks like something like this. So we get like x squared times x squared times x squared for 3 times since it's to the power of 3. So we get a total of 6x, so we got x to the power of 6. The exponents of the answer is the product of the exponents. So x was like x squared to the power of 3 is equal to x to the power of 2 times 3, which is x6 to the power of 6. In other words, when raising an exponential expression to the power, we write the results of its common base and the product of x1. So for any real number a and positive integers b and c, the power rule of x1 states that a to the power of b parentheses to the power of c is equal to a to the power of b times c. Notice the difference between the product rule and the power rule. For product rule, we adds up the exponents, but for the power rule, we multiplies the exponents. Yeah. The next rule is the zero exponent rule. So return to quotient rule, we made the condition that b is greater than c, so that the difference b minus c would never be 0 or negative. What would happen if b is equal to c? In this case, we would use the zero exponent rule of x1s to simplify the expression to 1. To see how this is done, let's begin with an example. We got t to the power of 8 on the top and also t to the power of 8 on the bottom, so we can just cross it out and then we got 1. If we were to simplify the original expression using the quotient rule, we would have t to the power of 8 minus 8, which is just t to the power of 0. So if we equate two answers, the result is t to the power of 0, and which is 1, since for any non-zero number or any variable representing a real number, like for t, for any non-zero real number t to some power, like to the power of 0, it is always equal to 1, no matter what. The next rule is the negative rule of x1. So another useful result occurs if we relax the condition that b is greater than c and the quotient rule even further. For example, can we simplify h to the power of 3 over h to the power of 5? In this case, b is equal to 3 and c is equal to 5, which b is less than c. Of course, we can do that. So if we just written out all the h's for the top and bottom, we can cancel out 3 on top and 3 on bottom, and we get 2 left on bottom, which is just 1 over h times h, which is also equal to 1 over h squared. So if we do it in the quotient rule way, we would get h to the power of 3 minus 5, which is h to the power of negative 2. The negative here represents that h is supposed to be on the bottom, which is also equal to this one. So it's just 1 over h to the power of 2. So also using the scientific notation, a shorthand method of writing a very small and very large numbers is called scientific notation, in which we express numbers in terms of exponents of 10. To write the number in scientific notation, move the decimal point to the right at the first digit of the number. Write the digits as a decimal number between 1 and 10. Count the number of places in n that you move the decimal point. Multiply the decimal number by 10 raised to the power of n. If you move the decimal left, as in the very large number, n is positive. But if you move the decimal right, as in the very small large number, n is negative. So for example, consider the number 2780418. Move the decimal left until it is to the right of the first non-zero digit, in this case 2. So we the decimal start from here. So if we just start from here, and if we just move left all the way to after the 2, which is the first non-zero digit, we have to move 6 places left, so it will be 2.780418 times 10 to the power of 6. Yeah. So let us do some practice question. Using the product rule, write each of the following products with a single base. Do not simplify further. So I will give you guys about 30 seconds to do each question. So yeah, let's start now. Alright, so the answer for these three are the first one, just t to the power of 5 plus 3, so it's t to the power of 8. And the second one, we got same base here. We don't have it right, like negative 3 to the power of 1, since it's just negative 3, so we got negative 3 to the power of 5 plus 1, which is negative 3 to the power of 6. And for the last one, we got like 2 plus 5 plus 3, which is 10, so x to the power of 10. Yeah. Okay, so the second practice question. Using quotient rule, write each of the following products with a single base. Again, to not simplify further. So again, I'll give you guys 30 seconds to work on these, starting from now. Alright, so the answers for these are, first one, just negative 2 to the power of 14 minus 9, which is just negative 2 to the power of 5. And the second one is t to the power of 23 minus 15, so we get t to the power of 8. For the last one, they both got the same base, c, and then square root 2, so we got c square root 2 to the power of 5 minus 1, which is just z square root 2 to the power of 4. Yeah, so the third practice question. Using a power rule, write each of the following product with a single base, and do not further simplify. So again, I'll give you guys 30 seconds to work on these, starting from now. These are pretty simple, so for the first one, we just multiply 2 with 7, so we got x to the power of 2 times 7, which is just x to the power of 14. And for the second one, we got 2t to the power of 5 times 3, so we got 2t to the power of 15. And for the third one, we got negative 3 to the power of 5 times 11, which is just negative 3 to the power of 55. And the next practice question, using the zero exponent rule. Simplify each of the following expression using the zero exponent rule of exponents. And I'll give you guys like for a second for this one, since it's harder than the previous one. Yeah. So the answer for these three questions are, first one, just 1, and second one, it's negative 3, since if we just cross out like x to the power of 5 from both top and bottom, we get like negative 3, since it's multiplied with that. So we got negative 3, and for the third one, we got 2, like 1/2, since it's 1 d e to like de cubed, and then it's over 2 de. Wait, oh, wait, I think I made a mistake here. There aren't supposed to be a square here, but anyway, if we just ignore this square, then we get 1/2. Yeah. So the last practice question. Oh wait, no, it's actually we still got one more. So yeah, practice question number 5. Using the negative exponent rule, write each of the following quotient with a single base. Do not simplify further. Write answers with positive exponents. So I'll give you guys first like 30 seconds to work on these. Starting from now. Yeah. Alright, so the answers for these questions are 1 over x to the power 7, since 3 minus 10 is negative 7, and then we just like ignore the, no, not ignore, we cancel out the negative from this, and then we put it on the bottom of the fraction. So yeah. For the second one, 3 minus 4 is just y to the power of negative 1, which is also equal to 1 over y. For the last one, we got negative 5 to the power of 3 times 4, wait, to the power of 4, sorry, minus 8. So we got negative 5t to the power of 3 to the power of negative 4, which is just 1 over negative 5t to the power of 3 to the power of 4. Yeah. So the last practice question. Write each number in scientific notation. I'll give you guys for like 20 seconds for these ones because it's really easy. So yeah. Alright, so the answer for these are 1.52 times 10 to the power of 5, since we moved the decimal point 5 places left. So, and the second one is 7.158 times 10 to the power of 9. And then the third one is 7.15 times 10 to the power of negative 8, since we have to move the decimal like 8 places left. Yeah, so thank you for listening, and that will be it for today's lesson. Thank you.